to part 2 of greatest common factor, least common multiples lessons. So here is the continuation of this topic. Again, your table of contents is already filled out. You should have glued in the blue page 16, the yellow 17, and the 2 orange ones, 18 and 19, from yesterday. You have 3 more today. The first note sheet deals with the old way of finding GCF and LCM. It's still perfectly good for this extra part 2 version, and that is all about, it's not just 2 numbers now, we got 3 to deal with. And you can do the old version of finding GCF and LCM with 3 numbers as well. So I'm going to do those, and then I'm going to move on to the Venn diagram line. So, just like with 2 numbers, with 3 numbers, you have to find the factor rainbows for all 3 numbers first. So here's 4. There's only 3 factors. 8 will be 1 and 8, and then 2 and 4. And then 20 will be 1, 20, 2, 10, and then 4. Notice how I always go from 1 all the way in and then go up 1, 2, 3 and try to find the factors that way. It's more organized and you make sure that you don't forget it. Now we're going to circle just like before, but we're going to look for what is in common in all 3 lists. So we have our 1s, we have our 2s, and we have our 4s. So greatest number that is in common that we circled will be the GCF, which is 4. Again, good thing to do when the numbers are smaller, like this example. Moving on. LCM with these same 3 numbers, we're going to list out multiples. Now, it doesn't matter if you do it horizontally or vertically. I know I did it vertically in the video for part 1. I'm going to do it horizontally here to show you just the differences. And again, I'm going to be thinking 4 times 1. And I'm going to write 4. 4 times 2. 8. 4 times 3. And so on and so forth. 16. 4 times 5. 20. Now I'm going to stop there for a minute and do the multiples of 8 and 20 and see what I'm getting. So I'm thinking in my head, 8 times 1. Writing down 8. Thinking in my head, 8 times 2, writing down 16. 8 times 3, writing it down, and I've noticed something. I've already passed 20. That means I'm going to have to go back and finish and add on to the list for 4. So let's do 20. 20 times 1, 20 times 2, and 20 times 3 will be a good enough start. So I know it's not going to be 20 because it has to be in all 3 lists. Now let's keep going here. 24, 28, 32, 40. I'm liking this. I'm thinking this is going to be it. So 8 times, we left off at the 3 here. So 8 times 4. And then 8 times 5. Bingo. I found a winner in each row. So the LCM is going to be 40. Okay. So that is 3 numbers, finding the LCM, GCF, the old way. Now we'll go on to the new way. So when using the Venn diagram with 3 numbers, everything's the same except for we have another factor to deal with. So the first step is to find the prime factorization of all 3 numbers. So doesn't matter which factors you pick. That's the beauty of prime factorization. I'm going to do 6 and 10. I'm going to ask myself, are any of those prime? A negative. So we're going to do another row. 2 times 3, those are both prime, and then 2 times 5, and I am done when I have all of the numbers in a row that are prime numbers. So I can move on to 36. I have 6 and 6. Those are not prime. I need another row underneath. Now, with my 2s and 3s, I have an entire row of prime numbers. I'm done. The fun thing about 15, after one factor layer or row, I am done because 3 and 5 are prime. Step 1, all set. Now we have to organize each one of these. So I have the steps along the side. I'm going to try to do all of the rest of this on one piece of paper and reminding you of what step is what as I go. So step 2 was we had to take those prime factorizations that we just did and organize them. So the first one we had was 60. And if I remember correctly, let me get my cheat sheet here. Yay, I'm on the orange paper now, by the way. Sorry for that. If you haven't figured that out, we are on the orange paper. 60, we had a 2, a 3, a 2, and a 5. So I'm going to put the 2s first, then the 3, and then the 5. Yay. 36 was that 2 times 3 times 2 times 3. So I'm going to put the 2 2s together and then the 3 3s together. Nice and organized. And the 15, there's not much to do. It's just 3 times 5. Now step 3 is to circle. I'm going to grab a couple of colors and I suggest that you do as well. So my blue and red here. I'm going to look first, and with one color I'm going to circle any number that exists in all 3 rows. And I see that there is a 3 in all of the rows. That is going to be one color. I'm going to circle that. It's a funky circle, but it is. Then I'm going to look to see, are there any other pairings? As in, are there any other repeating numbers in any of 2 rows? And I can see that there's a 2 and a 2 between the 60 and 36, and that actually happens twice. And then there's another one. Do you see it? There's a 5 over here in the 60s row, and then there's a 5 down here. So those actually connect. I'm just going to kind of draw a line to connect them. So I have step 3 done. Now, drawing a Venn diagram is not that hard. I'm going to show you how to do a regular 2-circle Venn diagram and then how to add a 3rd circle. So the regular Venn diagram just starts out with a circle. And I've made mine kind of like someone sat on it a little bit. And then I'm going to do another one to the right. So you've noticed I have a section in the center and left and right. Now, in order to do a 3rd circle, I'm going to start in the middle of this football in the center, and I'm going to just go below. So I have made 3 circles. There's a center part where all 3 intersect. I'm going to highlight that the same color that I did my 3s. Because step 5, when we're putting all the numbers in, this center part is what all 3 numbers have in common, and that is that 3. Now, what are the 3 numbers? Don't forget to label, because it's very important to do that. Let's put the 60 over here. That's this left-hand circle. I want you to do the same labeling as I am. We're going to put the 36 over here, and then the 15 down here. Okay? Now let's attack my red circles. What's in common between 60 and 36? We've circled 2 pairs of 2. So just like yesterday with a regular Venn diagram, the part that's overlapping between 60 and 36 is this little piece right above the middle guy. So we're going to put 2 2s only in that section. That's not 22, it's just 2 2s, because there are 2 circles that have a pair of what's in common between those 2 numbers. The only other thing that's in common is between the 60 and the 15. So I'm going to look at what piece is shared by just the 60 and the 15. And that's this piece right here. I'm going to put the 5 over there. Now my red numbers are done. The last thing you want to make sure is that there is no other numbers that have not been circled. This 3, if you look closely, this 3 we didn't do anything to. That 3 is in the 36th row. So way out here are the numbers that are all by themselves. They didn't get a pair, they don't have a match. Oh well, they're going to be alone for the rest of their lives. That 3 goes on the outside part, not the outside, but the outer part of the Venn diagram. And that is how you fill in the Venn diagram when there's 3 numbers. It's a little bit trickier, I know, but the center is what all 3 have in common. And then this second layer, the second layer of the flower, so to speak, kind of looks like a flower, kind of, is where the pairs of common numbers go, and then the oddballs out go on the outer edge. Now, finding the GCF, finding the LCM. So, just like before, whatever's on the inside, we're going to multiply together. There is only one number, so we can't multiply 3 times 2 and get 6. If there was a 2 in there, we would and get 6, but the GCF is just going to be 3 for this problem. Now, let's do the LCM. LCM, just like before, you're going to take all the numbers inside and multiply them together. So, LCM, we have a 5, a 2, a 2, a 3, and a 3. And there's no wrong way to multiply these. So I'm having a 10 and a 6, and then this 3 is still on the oddball outside. So now I have 60 times 3, and the LCM is going to be 180. Now you know why I prefer this for 3 numbers or big numbers, because we would have to, the old way, go to multiples of 180 before we found a match. So this is a little bit quicker. So the last piece of this video is dealing with that green piece of paper. Good thing is you don't have to write anything on this piece of paper, but it's probably the most important one of all 7 pages that I've given you. That's why it's a totally different color. Yay. So you should have page 20. Ta-da! Page 21, ding, ding, ding. We just got done with that. And now the last page that you're going to glue in your notebook, page 22, is this baby right here. When you have word problems, you're not going to be told, for the most part, find the greatest common factor. They don't make it that easy. So you have to be detectives and think, okay, are they asking us to find LCM or GCF? And here are 2 clues and hints to help you. If they say greatest at all in the problem, they're asking for the greatest common factor. So that one's kind of easier to pick out. LCM is when something is being described like music lessons or art lessons or practice times. And they give you all this information, and then at the very end they say, when will this happen again? So that's a clue to say, oh, okay, we're going to take these numbers and find the LCM of them. And I'm going to give you the 2 examples of ones that you might see, one of each. So here we have, Amy has 35 roses and 56 tulips. What is the greatest number of bouquets of flowers that she can make if she wants the same amount of roses and tulips in each bouquet? So, greatest, you heard me read that with enthusiasm and hint, hint, hint. Greatest number of bouquets means we want to find the greatest common factor of 35 and 56. So, if I'm really, really, really spot on with my math facts, I will pick out that the fact family of 35, that's the same of 56, is 7 times 5 and 7 times 8. So the greatest common factor will be 7. I can make 7 bouquets where there will be 5 roses in them and 8 tulips. So this was something that you could do the old way, that's fine, or you could do the greatest common factor of those two numbers using the Venn diagram, even better. But this is an example, really, I wanted to show you what, not just the answer, but what the word problem looks like. The word greatest was in there. Now for LCM. Here's something that will ask us, when will this happen again? An airport offers 2 shuttles that run on different schedules. If both shuttles leave the airport at 4, at what time will they next leave the airport together? So something happened, and when will it happen again? When will it happen next? That's the big idea. And so now we have the information here. The shuttle A departs every 6 minutes, and shuttle B departs every 9 minutes. So the important information to find LCM and GCF of is actually the 6 and the 9. The 4 o'clock is important as well, but for later. And this is the question. At what time will they next leave the airport together? This next leave, it's happening again. That's LCM. Notice I'm marking up my problem according to the cube strategies. And at what time is also an important thing to note. At the end of the day, we're not looking for the LCM. We're looking for the time that it will be when they meet. So I am going to walk this one through for you for a little bit. So I'm doing multiples, 6, 12, 18, and I can stop because I know 18 is also a multiple of 9. I did use, because the numbers were small, the old way, perfectly good. Now, the answer though is not 18. It's not going to be 18 minutes, it's not going to be an answer of 18 because they want to know the time. So if they leave at 4 o'clock, 18 minutes later is when they'll meet and depart together again. So 4 o'clock plus 18 minutes, you guessed it, the real answer is 4:18 p.m. Again, we're going to practice LCM and GCF all day tomorrow. I hope you have a good night and get ready for some word problems.